and welcome to the Daily Space Weather. Strap in or strap on your strap on or do whatever you're going to do to prepare for this one because it's going to be long and I might snap into a frenzied rage. So here we're looking at the northeastern limb and we've got some new sunspots that just rose up there in the northeast. They're kind of small at the moment, but there may be some larger activity behind them. We'll have to wait and create suspense in the meantime. In the northwestern limb, there's some filamentary activity going on up there for sure. And some minor active regions. You can see those bright areas showing up in our 24-hour video there featuring 304 plus 193 angstroms. If you see that wobbling around, that's from the SDO's calibration maneuvers to make sure it's centered on the solar disk. We've got this large sunspot just moving past the Earth-facing vicinity here. It's been showing some flaring activity, but the main place to really watch is indeed in the southeastern limb. So that is a big deal. There are 5 sunspot groups there now. Okay, so it was 1, then 2, and then now we're at 5. You understand how to count from 1 to 5. We're hoping that you have a high school level of physics understanding. Again, this area is extremely likely to produce large flares. We've seen just a general uptick here in solar activity. So here's the full disk view. You can see that SDO calibration maneuver. Hopefully it's not enraging you too much. And hopefully nonsense on YouTube isn't enraging you too much. And we hope your devices are working well. So, yeah. Let's take a look at some more full disk imagery here. We've had a rapidly growing additional sunspot group here right in the equatorial region. Check it out right there. Northwest of 3272. So huge uptick in sunspot number, big uptick in the radio flux today also. We'll get to it here. We're going to do a cosmic ray report. There are a lot of things to cover, and it's going to be a very, very good video today. We're sort of stoked about the content. Let's talk about supporting the channel. So we've done the math, and we've noticed that there are a lot of people that are bad at math on YouTube. Anyway, one of our latest products is Do the Math. So tell your friends and foes to follow our equation. Now, Big Tech did the math. This is part of the reason why we have to have merch. Because if you'd like to see these videos continue to exist, remain publicly visible and free for all to view, please support the channel. One of the ways you can do so is with these tangible products. We invite you to do the math. And the math is 8 = capital D. Write it down. Tell your friends and foes to do the math. This imagery doesn't feature empty space at all. It actually features the brightest intrinsic object visible from our solar system, visible right there near the first equal sign. That's Deneb, otherwise known as Alpha Cygni. Links below the video to our merch shop. You can also find links on our homepage, and you can also find links to the Smash Team. So smashomash.com/Smash Team is indeed the official homepage of the Smash Team site. If you want to support the channel that way via subscription services, thanks to everybody who has, by the way, consider becoming a member of the Smash Team at the bronze, the gold, or the silver level. The best value is the annual paid-up gold subscription. Thanks to everybody who's trusted us with an entire year of content. We appreciate that. It really helps our operations as we roll back we roll the cash back into the channel. Links below the video and the homepage, and on the homepage to that. Also to the Hemp Lucid shop. There's a huge sale going on, the 420 sale. It ends 421. So perhaps assist us this way, and perhaps assist your health by visiting our sponsor/affiliate links. And if you're just on hemplucid.com, enter the promo code SMASHOMASH to save some dough on checkout. Not sure what to try? Take the quiz. Hemp Lucid, our latest affiliate/sponsor. Again, links below the video and on the homepage at smashomash.com. And welcome to the Neo Renaissance. You can also find links to our permanent link to our Discord chat. You need an invite to join a Discord chat. You can find our Patreon, our Instagram, if you want to follow things like fitness and lifestyle stuff. Lots of that going on Instagram. And let's take a step back here and take a look at volcanoes. So, we're going to show some incredible imagery of Shivaluch later in the video. Shivaluch continues to erupt in an explosive fashion and produce a 32,000-foot plume of volcanic ash. Please do not pole vault the Kamchatkan caldera. Subanosejima exploding, also flight level 080. Ibu exploding, flight level 060. That's a 6,000-foot ash plume. Semeru exploding, flight level 130 over East Java, Indonesia. Flight level 220 over Popocatépetl from explosive activity there in central Mexico. Nevado del Ruiz showing elevated seismic activity, also eruptive activity. 7.8 kilometer ash plume there from Nevado del Ruiz in Colombia. Now headed down to Ecuador. Exploding is Sangay. It's producing a 21,000-foot ash plume. Revenador producing a 14,000-foot ash plume. That's a flight level 140 and a flight level 230 over Sabancaya in Peru as Sabancaya explodes. It's a 23,000-foot plume of volcanic ash. Don't pole vault that caldera either. Next, the 90-day bar graph here. We've had low seismic activity in the past 24 hours. Let's do a 24-hour rundown here. We'll cite quakes over a 5 magnitude. Still a bunch of quakes happening there around the California coast. And remember, folks, any earthquake can be a foreshock. Even if you see a magnitude 7, that could be a precursor to a magnitude 8. So just be aware of this. And if you're in an earthquake-prone zone, know which buildings might collapse if you evacuate yours. So in the past 24 hours, we did see a couple 5-plus magnitude quakes, but not many, like this 5.1 in the southern Indian Ocean and this 5.0 at extreme depth, by the way, over 500 kilometers south of the Fiji Islands. Again, a swarm of earthquakes there showing up on the U.S. West Coast once again, otherwise known as the left coast. Nicobar Islands in the eastern Indian Ocean also had a 5.2, and the Owen Fracture Zone had a 5.4 at the other side of India in the northwestern Indian Ocean. So some activity showing up there. And let's get back to space. And here's our house favorite wavelength. Cheers. The 171 angstroms, pure goodness. And let's show a brief close-up here as foreshadowing of what's to come. Large solar flares, coronal mass ejections, etc. These 5 sunspots have, they've they've increased the likelihood of large solar flares like X-class flares a lot. We are currently in a solar flare watch mode. There could be one happening as we stream this video. So we're going to talk more about solar data here. Let's do a cosmic ray rundown. We haven't done one for quite a while. So if you're not familiar with cosmic rays are high-speed particles traveling through the universe at nearly light speed. It's very difficult to determine point sources for cosmic rays as they are affected by magnetic fields. They want to orbit those magnetic field lines, and those alter their courses through the universe. So again, it's very difficult to determine where they come from. They're mostly made of similar chemical components as the solar wind, mainly hydrogen nuclei, also helium, electrons, and other heavy elements. Elements up to the mass of lead have been measured in cosmic rays. And there are all kinds of different ways to measure the cosmic rays. We can even look at historic cosmic rays by looking at the ratio of carbon-12 to carbon-14 in tree ring data. So cosmic rays are super important as they tell us some stuff about what's going on not only within the solar system, but without the solar system. So if you're not familiar with that, there's a great article here. It's a great series of articles, actually. Imagine the Universe. That's imagine.gsfc.nasa.gov. And here is our cosmic ray data. So we're going to go through in alphabetical order here. We'll look at Apatity and Barentsburg first. So there's Apatity's neutron monitor. And over the past 30 days, it's flat over the past 30 days, despite significantly increased solar activity. Barentsburg, there's a downtick over the past 30 days, perhaps more likely to be the pattern here. Let's take a look at some more cosmic ray monitors. Such as Athens, Greece. Am I going forward or backward? I'm going backward. So next we'll move much farther south to Athens, Greece. By the way, Athens Neutron Monitor page has a great link, this neutron monitor database. You can plot multiple different cosmic ray monitors at the same time there. Athens showing an uptick over the past 30 days and some missing data for the past 3 days. So that's a little bit inconclusive there. Let's move farther south to Mexico City. Mexico City flat over the past 30 days. And cosmic ray flux at Oulu, Finland, showing an uptick over the past 30 days, despite the downtick in solar activity. Now, you may not be aware of this, but solar activity is inversely proportional to cosmic ray flux, going back at least 1,000 years, probably a lot more than that. There is a inverse proportionality to cosmic ray flux, meaning when we have a lot of sunspots, we have low cosmic ray flux, and when we have solar minima, we have high cosmic ray flux. Anyway, thanks for leaving a comment. Robert, good morning to you as well. So that's Oulu, showing a little uptick here in the past 30 days. Let's look at Antarctica last. There is DOMB Antarctica, pretty flat over the past 30 days, and DOMC Antarctica, a slight uptick there like Oulu. So flat to up over the past 30 days, despite an increase in solar activity recently. So the 10.7 centimeter radial flux is now all the way up to 154 solar flux units. Let's put that in context. This black line here is the 10.7 centimeter radial flux, and we can expect a huge uptick in both the sunspot number and the radial flux today. The radial flux is going to go over 170 today, and the sunspot number is going to be over 160 today. So expect a huge uptick. And everybody will be talking about it all over the internet, and they'll be trying to convince you that the only thing scarier than an inactive sun is an active sun. And both of these concepts are utter nonsense, so please take it with a grain or perhaps a truckload of salt. NOAA's not forecasting any geomagnetic storms or geomagnetic unrest. Actually, they are forecasting some geomagnetic unrest late in the day on the 15th. So I'm not sure what that is. Maybe they watched our channel and noticed that we forecasted a CME. So we are expecting a CME to arrive mid to late day on the 15th. So that's when you can expect that to show up. It's going to be minor, but there may be a good signal, as we are expecting the coronal hole high-speed streams to be subsided by then. So late in the day, mid to late day, universal time on April 15th, expect a minor coronal mass ejection impact. We could see KP5 or KP6, depending on the magnetic field intensity and the vertical component of that magnetic field. Speaking of magnetic fields, here's Earth's magnetic moment from space. This is the past 4 hours of magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework, which is a very complex model. It uses all sorts of things like magnetometers, the solar wind, speed, density, magnetic field parameters, and so on. It's pretty calm in Earth's magnetic moment. Here's Earth's magnetic moment from the ground. And fun fact, if Earth's poles were really in the process of actually shifting and reversing, you would see this getting all weird. It's not like an extreme polar excursion. The magnetic poles are as much more likely to snap back toward the geographic poles than they are to reverse or to go into an extended magnetic excursion. That's the past 4 hours of Earth's magnetic moment from the ground. Look how calm things look. Geomagnetically speaking, we have a KP 0.33, so almost a KP0 situation. Again, extremely calm as far as the solar wind parameters. Let's take a look at the solar wind parameters, which are measured out here at Lagrangian point 1 outside of Earth's magnetic field, about 1 million miles toward the sun from planet Earth. Current situation is just under 400 kilometers per second for the solar wind velocity, solar wind density, less than 3 protons per cubic centimeter. We do see some drifting of the magnetic field there. We see a pretty flatline signal there from the plasma temperature. It's fairly unremarkable. Let's look at magnetic data next. There are your GOES magnetometers. Pretty smooth here. Again, it looks like the coronal hole high-speed streams have ended. And you could see a couple little upticks here from additional coronal hole high-speed streams, as there are some rather undefined coronal holes out there. Next, we're looking at the heliospheric current sheet. And there is a South Pole current sheet headed this way, and then slowing down there. So, yeah, that's interesting. Also note this movement of this magnetic field around the north heliographic pole. We can see that starting to try to move down, it looks like. That is the solar polar field reversal process, which is perhaps even more important than sunspot production. Next, we'll take a look at the line of sight field plot. Here the sun's B field is depicted in blue. It also shows the SDO magnetogram. And the polar fields depicted in green for north and red for south. Next, coronal holes. Super important to the solar polar field reversal process. The process that occurs along with the sunspot cycle. Yeah, the poles reverse on the sun every about 11 years. So lots of North Pole-oriented coronal holes here facing Earth, and we've got some South Pole-oriented coronal holes rotating in here down in the southeast, right around that series of very strong-looking sunspots. So here's the past 24 hours in SDO 211 angstroms. So these will be South Pole. Let's mark these up. These will be South Pole down here. And these, all the rest of these are North Pole, North Pole. Wow. I'm getting massive delay here. I apologize for my terrible writing. Anyway, those are North Pole. The only South Pole ones on the Earth-facing portion of the solar disk are down here in the southeast. They will become more well-defined in a couple of days. Let's move to sunspots next. And by the way, counting sunspots is not going to magically cause you to understand solar cycles. We just accidentally figured out the solar cycles and the mechanism that causes them. And, you know, that's just one of those things that happens in science. Immerse yourself in the data and strap in your strap-on, because your safety belt is going to require additional... Anyway. Likelihood of large flares is nearly 100%. Expect M or even X-class flares, especially from this southeastern limb, but also 3272, and even this new sunspot. There's a new sunspot right here that's going to get a name, and that's going to add like 70 sunspots to the sunspot number today. It's a huge uptick. So let's take a look at some sunspots here. What is going on? All right, that was my fault. And I mysteriously have misplaced data that I thought I downloaded. How about that? So that's fun. So just bear with me a minute here. We'll just put up the SDO intensity gram. Let you know that it is yesterday plus today's data. We showed this earlier in the video, but let's show it again since we're on sunspots. So here's yesterday plus today. And you see this sunspot group rapidly form here. Also another group forming down here, or rising. 2 new groups rising down here. So we'll have 5 sunspots down here, a new one around the equator. It's a huge solar uptick. Them's the facts. If you're angling for a grand solar minimum, you're getting skunked today on your fishing excursion. So just abandon that nonsense. It's silly and ridiculous. Next, looking at energetic particles. Proton flux not showing any spikes here, but don't be surprised to see some solar energetic particle events, especially if we see major flares, as they typically accompany major flares. And there's the GOES X-ray flux, which you can see is rising massively. So a huge uptick, as we forecasted. That little lull there was just to tease grand solar minimum noobs and their silly Valentina Zarkova cult, relying on one paper and sitting around with their fingers crossed, hoping that the sun shuts down because they want to be right. So check it out. I mean, this is like a major sunspot group down here, and we're going to bring up a full disk image. This is 94 angstroms all by itself. That is yesterday plus today's data. Give that a minute. There we go. So the major players are going to be right here, and especially right here. Those groups are, especially these groups down here, these are they're complex. There's a lot of magnetic field complexity going on. We'll show you that later in the video. Here's some more imagery. These are more 24-hour videos from SDO. This is 131 plus 171 angstroms. Not the best time for those SDO calibration moves. And let's take a look at a star chart. So before we move on here, this is what's going on over Lehigh Valley, Pennsylvania. If you want to make your own star chart, head to skyandtelescope.org. If you want to use the same one we're using, just put in your location, and you can see what's going on overhead as Jupiter and the Sun are chasing Saturn across the sky, and Mercury is chasing the Sun. Also, the Moon is visible currently over Lehigh Valley, Pennsylvania. And let's do a solar system forecast. So here's where things are now. We'll move heavenly bodies ahead 1 week to show you that 1 week forecast. Here's where things will be on the 20th. It looks like 420 will also be the new moon. Everybody will be sleeping well, perhaps especially if they picked up our sleep-enhancing gummies from hemplucid.com. Okay, so next coronagraphs, we're looking for CMEs. We do see some CMEs occurring there. That's yesterday's 67 frames. See Jupiter sliding across the bottom of the frame there. And here are today's frames, 35 additional ones. And we're seeing a halo there, so there's definitely a halo showing up. That looks like a Earth-directed coronal mass ejection, perhaps. Let's take a look at some more data here from Stereo A and Soho Lasco C3. Let me go back a minute here just to see the time for that. So that appeared around 0 dark 24. So early this morning. Let's see if we can see anything on the other imagery here. Could be an Earth-directed CME, folks. Fingers crossed. All right, let me bring this back. Does Stereo A have the data? I don't see anything. Could be some kind of an error. Let's see what we see on here. Oh, there is certainly some ejecta there. Not so sure it's earthly directed, so let's take a look at our 24-hour coronagraphs. Let's get a little closer than that. There we go. I don't really see the origin of that, so my best guess is that it's on the opposite side of the sun. Usually with 193 angstroms, you'll see some sort of activity there. When you see a halo, it's usually from the center of the solar disk. So just after midnight here, this is another 24-hour SDO video. So I don't suspect that is an Earth-directed coronal mass ejection. Let us know in the comments if you disagree. And thanks to everybody who's been leaving comments. It's always a delight interacting with people just like you. And fun fact, we don't think that our viewers are morons. I know there are many YouTube channels who believe that their viewers are complete idiots. We are not in that realm. We think our viewers are smart. In fact, we think humans are generally good. How about that? It's crazy. Next, looking at filaments, and again, like we started out the video with, we showed great imagery there at the beginning to show some filaments, but a massive number of filaments here, mainly around the edge of the Earth-facing solar disk. Huge filaments, and if you want to name them, join us on Twitter. So we've created the hashtag over there, Name That Filament. If you want to name filaments after your favorite living humans, again, just join us over here on Twitter and make sure you follow the hashtag Name That Filament. Also follow the hashtag Space Weather over there on Twitter. You'll see content that you won't find anyplace else. And we don't name filaments on YouTube comments. Make sure you name them over on Twitter. And allow me to pause for station identification. You've reached the Smash News Network, least busted name in news. And congratulations on realizing the channel exists. Here's the past 24 hours in SDO 211 plus 171 angstroms. These wavelengths are great because they show the lower corona, especially 171 angstroms, and then the extended corona, as well as coronal holes. That's the 211 angstroms portion. A quick reminder to keep an eye on that area down there. And when I say eye on, pardon the pun, it was intentional. And let's see what's been happening in the past couple of hours here. So this is the past about 2.5 hours from the GOES 16 SUVI. And no, that's okay, Windows. I'll wait for you to respond to my commands. You take your time. Take your good old time, Windows. Microsloth, an organization who's been writing barely functional software since Windows 3.11. Although not as pathetic as Google. Yeah, the Android device, some of the worst software, like Facebook, in the history of software. Yeah, so here's the past about 2.5 hours in the GOES 16 SUVI with its spectacularly wide field of view. A great place to follow coronal mass ejections as they eject, which is why we stream it regularly on the Twitch channel. And of course, we would never tell you to not visit the YouTube channel, twitch.tv/SmashOmash. Let's move to our bonus features segment. Satellite charging hazards. We ain't got none. That's the satellite's community dashboard, if you're wondering. Electron flux remains low, and we're expecting an uptick in this. Let's see what NOAA's expecting. The green boxes will be the forecast, and NOAA's expecting a downtick. So I'm not so sure about that. We're expecting this a little higher, but hey, no big deal. Who's worried about the electron flux anyway? By the way, it's measured at the F layer of the ionosphere. Here's a 1-year graph of the relativistic electrons, as measured by the GOES 16 and GOES 18 in their geosynchronous near equatorial orbits. They measure it at the F layer of the ionosphere. And feel free to pause the video on this frame. Oh, and a quick note. If you're not familiar with atmospheric layers, here's a little primer for you, which may help you out a little bit. Feel free to pause the video on this frame or on this frame, because the temperature is inverted in each layer of the atmosphere. So the troposphere is warmer at the surface, the stratosphere is warmer at the stratopause, the mesosphere is warmer at the warmer. You get the idea. The layers are hot to cold, cold to hot to cold, and cold to hot. Keep in mind also you've got less and less material. So you've got not a lot of material up here, quite a lot of material down here, and a massive amount of material down here, like quadrillions times more protons in the troposphere layer, like at sea level, than up in space. So just so you're aware of that, these systems are a little bit more complex than just the solar wind just heats up the atmosphere. That's not really the way it works. It's a lot more complex than that, just so you are aware of that. So here's the ionosphere. This is just the raw vibrational frequency. You can view this data yourself if you like at the Australian Government Bureau of Meteorology website. It's showing millions of vibrations per second at about 300 kilometers of altitude, the location of the F layer. And we're seeing some major anomalies here, especially the low-frequency anomalies around the Southern Atlantic Ocean and the South Atlantic anomaly. They're evident to me, but they might not be to you if you're not familiar with looking at this data. But don't worry, we've got the anomalygram. So, of course, that is why we show the anomalygram, because it's a little weird looking at the ionosphere. So No, you take your time. You take your time. Oh, fantastic. All right, no problem. So for some reason, one of our tabs has timed out. And that, as you may have noticed, is pissing me off. All right, so here is the anomalygram. We're hoping. And you're going to see a lot of red on the map here, especially around the South Atlantic anomaly, which is right about here where my pointer is. Right over sort of the middle of the South American continent. It's Earth's weakest point in the magnetosphere. And not surprising to see anomalies right there, but those huge anomalies there, those are anomalous anomalies. Anyway, here's the latest image. 12:15 Universal Time. Ionogram and 12:15 Universal Time anomalygram. Continuing on to the total electron content forecast. The free electrons between your GPS satellite and your GPS handset can cause signal refraction. And here it is, we're hoping. Oh my gosh. Wow. So here's your total electron content forecast. That's going to show you the most likely places for GPS errors. And things are fairly organized here. We see this get a lot less organized during things like major coronal hole wind streams, coronal mass ejection impacts. When we see a more nominal level of electron flux, we see this a little bit more orderly. And we're expecting an increase in the electron flux. Last but not least, we'll show the latest solar intensitygram and solar magnetogram. And indeed, that is a lot of stuff going on. So again, we've got at least 2 new sunspots showing up in the northeast. At least 1 new sunspot. When I did show, oh, there's 2 umbrae there. Those are 2 new sunspots. But down here, that's the real, that is extreme. That's a lot of sunspots. Also, this new group that formed right here, just to the northwest of sunspot 3272. That's just a huge uptick in sunspots, period. I'm not going to really dwell on it. Let's move on to our our nullschool.net map. Now, we're looking at the lowest pressure in the world right now, which is in the Southern Ocean there near Antarctica. So, but we're not going to worry about that. We're going to show you a feature that you may not have been aware of. So, been a lot of talk about Shivaluch on YouTube. So let's talk about Shivaluch. All right. So there's the Kamchatka Peninsula, right? There it is, that peninsula right there. And if we look up particulates and the PM10, it'll actually show you the way the particulates are moving. And better yet, you can move this back to the day that it erupted, which was late in the day on the 9th. So check it out. There we are, 1700 on the 9th. You can see this major eruption. And there's a low pressure zone to the south of it. Okay, so at first, let's zoom in a little bit farther here to get a good view of this. So when it first erupted, you can clearly see that it's moving, the plume is moving to the southwest, right? Now we're going to move this ahead 1 hour at a time. So it's moving to the southwest, southwest. Give it a minute to download. By the way, our internet connection is blazingly fast. All right, so there's still moving to the southwest, southwest, and this low is slowly moving off the coast, right? So it's moving to the southwest, and now you see it kind of stagnates a little bit. That's when all the ash fell happened, because we had like neutral winds there for a minute. I think there were as high as like 6 inches of ash fall on the Kamchatka Peninsula. Now watch the ash plume. This is by the way, this is the particulates smaller than 10 nanometers. So it's going to show fine dust, ash, etc. Now, as we move forward here, check it out. You can see the particulate cloud here being pulled right into that low. It's just awesome. And by the way, if you think mankind controls the weather, look at these systems. These are huge. We're talking about hundreds of miles here. Mankind doesn't control the weather or the climate. Suggesting that mankind controls the weather or climate in any sort of major fashion is just ridiculous. Ridiculous. As ridiculous as the galaxy is dangerous. So anyway, let's zoom out here, because obviously that low is sucking up a bunch of gas and dust. And we're going to move this ahead at the 12-hour period. So now we're going to move it ahead 12 hours. "12 hours, 12 hours, 12 hours." Now we're into yesterday at 1400 Universal Time, 2200 Universal Time. Now we're into this morning. So that is slowly making its way across the Pacific Ocean. It's going to take a while to get to the U.S., and you can expect purple sunrises and purple sunsets as a result of that. Now we're going to skip the jet streams and surface winds because we don't want this video to be too lengthy. These are the clouds and fog over the U.S. and South America and Central America. And let's look at our weather.gov map. So lots of red flag warnings. And what are those tan areas? Pennsylvania is very tan here. Fire weather watch. So it's been very dry and very hot, actually, and it was pretty windy yesterday, too. If your location's lit, click your location. Hydrologic outputs, lots of flooding and additional snow coming. So let's take a look at some forecasts here. Here's the GFS forecast. Guess what? New Orleans is going to get hit again. So this system is just moving out, and there's another one moving right in. So in about 3 days here, that's a 72-hour GFS pressure and precipitation forecast, another strong system to move in from Texas. Also snow in the northwest. So here's your snow forecast. That's a 72-hour GFS positive accumulated snow depth change in inches. And here is our total accumulated precipitation forecast. You can see heavy rains there coming back to New Orleans. That is a 72-hour GFS total accumulated precipitation in inches. And let's show a little bit more information here. So here's this low pressure that's affecting Mobile right now. It's just to the south of Mobile. It's almost right over Mobile. That's the current weather situation. Look at how low the pressure is there around the Rockies. Windy.com, they got a great free mobile app if you've never checked it out. You can buy it from the Junkware Play Store or the Junkware iOS Store. Junkware, Junkware, Junkware. Run Linux if you want a secure computer. All right, so here's a lightning mapper. There's some lightning across North Dakota and Minnesota there. And let's see if we have any current strikes by consulting lightningmaps.org. And just minor lightning activity there, mainly off the coast of Florida, the Atlantic coast. And there's your full world view. And let's see if we can get through our final 3 tabs here without crashing. Don't worry, folks. We've only got like 80 tabs open. No big deal. What could possibly go wrong? What could possibly go wrong? It works great. By the way, we are about to upgrade our system here, thanks to especially gold annual paid up Smash Team level members. Here's our U.S. Doppler radar map. That shows vertical motion. Here's clouds and fog from the satellite's perspective. Those clouds and fog, they emit radiation at 3.9 nanometers, part of the infrared spectrum. And there you can see that rotating low as well. And it is surrounded by a bunch of dry massive air, which will not help to strengthen it. In fact, it's likely weakening it. So you see those huge pressure gradients being created there as that dry massive air swirls around that low, because lows suck and highs blow. That's a little atmospheric physics for you. Hopefully that helped. In the meantime, here's a recap, starting with U.S. Doppler radar. Clouds and fog. And there is water vapor. That should clear things up Thanks for tuning into the Smash News Network Least Busted Name and News. We hope that you're not enraged and ready to hit your computer with a sledgehammer. Don't forget to press the like button, subscribe, and share if you're new to the channel. See you soon. Congratulations on realizing the channel exists. Big Tech, you're doing a fine job. Slow clap for Big Tech. Thanks for making everybody so safe, Google. See you soon, viewers. And may that solar wind be at your back.